Question 12 has two options. Students have to answer any one of them, not both. But here I am showing the first option. So let's read the question. We have a curve that is y equals to 3x cube plus 2x square minus 5x plus 1. This is a cubic curve, and if we draw a tangent on x equals to minus 1, that tangent meets y-axis at point A. In the first part of the question, we need to find the coordinate of A. So let's start. Let's write y equals to 3x cube plus 2x square minus 5x plus 1. Now let's differentiate this y with respect to x. We get dy over dx equals to 9x square plus 4x minus 5. Now if we substitute x equals to minus 1 in dy over dx, it will give us the gradient of the tangent drawn at x equals to minus 1. So at x equals to minus 1, dy over dx equals to 9 times minus 1 squared, that is 9, then 4 times minus 1, that is minus 4, then minus 5 equals to 0. So gradient at x equals to 1 of this tangent is 0. Sorry, at x equals to minus 1. So let's get the y coordinate where x equals to minus 1. So x equals to 1, no, is we need x equals to minus 1. So at x equals to minus 1, y equals to, I am substituting the x equals to minus 1 in the original equation, so we get, so let finish writing. Let me finish writing. Plus 1, so that gives me y equals to minus 3 plus 2 minus 5 plus 1, which is equals to 5. So let me write y equals to 5. So now we need to find the equation of this tangent. So equation of the tangent at x equals to minus 1, we use the formula y minus y1 equals to m times x minus x1. Therefore we can write y minus 5 equals to 0 times x plus 1. That gives us y minus 5 equals to 0. Therefore y equals to 5. In the question it says that this tangent meets the y-axis at point A. At y-axis, x always 0. So A, the x coordinate of A is 0. Therefore we can write x equals to 0. So we can write the coordinate of A is 0, 5. So coordinate of A is 0, 5. Now let's move on to the next part of the question. So let me scroll the page. Yeah. Okay. It says that the curve meets the y-axis at point B, and then the normal to the curve at B meets the x-axis at point C. The tangent to the curve at the point x equals to minus 1 and the normal to the curve at B meets at point D. We need to find the area of the triangle ACD. So let's try to find the coordinate of the B first, and then the normal equation of the normal at B. So at B, x equals to 0. Why? Because it is on y-axis. So at B, y equals to, putting x equals to 0 in the original equation, we get y equals to 1. So the coordinate of B is 0, 1. Now let's try to find the gradient of the tangent drawn at B. That is, when x equals to 0, our dy over dx will be at b dy over dx equals to 0 plus 0 minus 5, that is dy over dx equals to minus 5. So gradient of the tangent at b is minus 5. So gradient of, now let's find the gradient of the normal at b. So gradient of the normal at b will be 1 over 5. Now I have the gradient of the normal and I know the coordinate of the b, 0 1. So I can easily find the equation of the normal again using the formula y minus y1 equals to m times x minus x1. We can write y minus 1 equals to 1 over 5 times x minus 0. That gives us y minus 1 equals to 1 over 5 times x. So this is the equation of the normal. It says that this normal meets the x-axis at point C. So we can write this normal line, this normal meets the x-axis at the point C. On x-axis y coordinates are 0, so therefore at C y is 0. So substituting y equals to 0, we get 0 minus 1 equals to 1 over 5 times x. So x equals to, let me adjust the view, okay, here. So x equals to minus 5. Now let write the coordinate of the C here. Let me draw a line. Okay, so the coordinate of the C is 0 minus 5 0. Now I have two equations in my hand. The one is a tangent at x equals to minus 1, that is y equals to 5, and I have other line, that is the normal, that is the equation of the normal is y minus 1 equals to 1 over 5 times x. So y equals to 1 over 5x plus 1. The question says that these two lines meet at point D. These two lines meet at point D. So therefore if we solve them simultaneously, we will get the coordinate of D. So let's solve. 1 over 5x plus 1 equals to 5, so 1 over 5x equals to 4, so x equals to 20. So at D the coordinate of x is 20. So coordinate of D is 25. Now I have all the coordinates of A, C, D, so we can easily find the area of the triangle. So let's write the formula. Area of the triangle ACD equals to half times, we can use the modulus formula, that is half times, then let's put the x coordinate of A, y coordinate of A, then x coordinate of C, y coordinate of C, and then x coordinate of D, y coordinate of D, and then again x coordinate of A and y coordinate. Now okay, here, well, now the arrow suggested the terms to be multiplied. So in the next line I will write half times 0 times 0 0, minus 5 times 5 minus 25, 20 times 5 100. So we add all of them, then I need to subtract. Let's put the other arrows here. These arrows, these terms will be multiplied and added. So minus 5 times 5, then 0 0, so I get only minus 25. Okay, so close the modulus sign. Then the next line, half times the half inside the modulus 100. So 100 divided by 2 gives us 50. So 50 units square is the area of the triangle ACD. So first option is done. Let's go for the other option.